here. We're going to talk about continuity today, you guys. Continuity is it's a very important topic in calculus. Okay, continuous means it doesn't cease, it doesn't stop, right? That's the English definition of the word continuous. It's ongoing. In mathematics, continuous means that it doesn't stop. It's non-ceasing. It doesn't, but maybe a better way to define it would be with the negative approach by saying what it isn't. It's like when a line isn't broken. It's a continuous line with no breaks in it. Okay? So that's what we mean by continuous. Now, I could draw you guys a quick little graph here. Is that a continuous line? Is that a continuous line?
No.
So it's that easy, honestly. That's what continuous means. Why is continuity so important? Well, as you guys know, the heart of calculus. What's the main thing that makes calculus calculus?
The long like rules and principles. We're just doing the math.
Limits.
The limits.
What makes calculus calculus is limits. That's where derivatives come from. It's about taking a slope and taking the limit of it as it approaches from 2 points to 1. That's how integrals work. It's where you take those rectangles and they become infinitely small. It's limits. Limits is the heart of calculus. So if you want to be approaching something and getting closer and closer and closer to it, then that line you're traveling on had better be continuous. So continuity is very important for calculus because if a line's not continuous, then calculus breaks down where the broken spot is. Okay, so continuity is a fundamental requirement for almost every theorem in calculus that we're going to look at this year. A function has to be continuous. So what we're going to look at today is how can you tell if a function's continuous? And if it's not continuous, you need to be able to explain why. You can't just say because it's broken. You can't do that. You have to actually define it mathematically. Okay? And so that's kind of the hard part, is knowing how to write the math answer for today, why it's not continuous. That's what makes it hard. But today we're going to talk about how can you tell if it's continuous or not, and then explaining why it's not continuous if it isn't. Now we're going to look at this in two branches. For today, we're going to look at the graph branch. We're going to look at a graph. We're going to find where is it not continuous. Oh, there it is. And then we're going to give the math explanation of why it's not continuous at that point. Thursday, when we finish the rest of this lesson, we're going to look at the equation side. We're not going to look at graphs, just an equation. How can you tell by looking at an equation where it's broken? Okay, so today is graphs. Thursday is equations. Okay. So, let's get down to business. So, introduction to continuity. This is an informal definition. It's very intuitive. A function is continuous if it's not broken. It has no holes, jumps, gaps, asymptotes of any kind. It's just one continuous line. But we need to get a little bit more technical. Okay, math is something where it's not okay just to rely on common sense to get an answer. You actually have to justify and prove that it's continuous. And that's actually, that makes things pretty complicated, pretty tedious. For instance, this function here. Here's a few different ways that a function can be broken, right? We could also include a third one, but I'll get to that maybe a little bit later. A fourth one, but we'll get to that later. But anyway, if you have a hole in your line, wouldn't that be discontinuous at that point? Okay, so if there's a hole and there's no solid dot at that spot anywhere, well, that means that the function doesn't exist. F of c is undefined. So if f of c is undefined, that's one reason why a function may be discontinuous. If you were to plug in this c value right here, whatever that x value is, there's no y value to go with that, right? So if there's no y value at that point, f of c is undefined, well, you've got a problem. It's not continuous. So there's one way. You guys might want to write that, by the way. F of c is undefined. Here's another one. If the limit doesn't exist, okay? In this case, the limit from the right, once again, you might want to write this. The limit from the right as x approaches c is not the same as the limit of our function as x approaches c from the left. So as I approach this x value of c, I have one y value here and a different y value there. So since the limit from the left and the right are not equal, the limit doesn't exist. And since the limit doesn't exist, that's another thing that can cause your function to be discontinuous, is if there's just no limit there. Okay? So that's two reasons why it might fail. Now let's go ahead and take a look at the last one. Is the function defined at that point? Is there a y value if I were to plug c into this function? Yeah, it's right there. It's that solid dot. So the function's defined. Does the limit exist? Are they approaching the same spot?
Yes.
They are. The limit exists. What's the problem? They're not the same. So even though the limit exists, so the limit as x approaches c exists, and even though the function exists, the problem is those two things are not equal. So those are the three criteria. Okay? First of all, well, these are the three, so let me rephrase myself here. These are the three ways. You guys are going to be writing one of these three things here today. Whenever I show you a point of discontinuity, you're either going to say it's discontinuous because it's not defined, the function is not defined at that point, there's no y value. Or you're going to say, because the limit from the left and right are not the same, the limit doesn't exist, so it's discontinuous. Or you're going to say, well, even though the function exists and the limit exists, they're not the same, so that's why it's discontinuous. So those are going to be one of your three explanations for why a function is discontinuous. Now, if all these situations are fixed, though, if you want a function to be continuous, then you have to fill in your hole. The function has to be defined. The limit actually has to exist. In other words, the pieces shut up. Yeah. You guys are the limit has to exist. They have to connect. Okay? And then finally, not only do the lines have to connect, but where they connect has to be where the y value exists. Okay? So the limit has to exist, the function has to exist, and those two things have to be equal in order for a function to be continuous. And that'll do it. So here's the more formal definition of continuity. A function is continuous at x equals c when these three conditions are met. F of c is defined. That means there should be no holes or vertical asymptotes at that point. The limit has to exist. You can't have any jumps or vertical asymptotes. Those two lines actually have to meet at a common point. And third, whatever the limit is, it has to be the same thing as the y value at that point. So there's your three criteria. Okay? So on your AP exam, they oftentimes want you to explain why a function is not continuous at a specific point. Or they want you to prove that it is. And to do that, you have to go through these three steps. I'm trying to remember, I think maybe last year's test actually had this on one of the three responses. But you have to go through those three steps. You have to prove that it's defined, you have to prove what the limit is, and then you have to prove that they're the same. All right, so let's go ahead and get started here. Example 1. All right, so the first thing I want to do is I want to find all the places where this function is not continuous. Okay, now here's how I'm going to do it. I'm going to start with my pencil over here on the left, and every time I have to pick up my pencil, at that x value, that's a point of discontinuity. So, boom, I got one there. So I'm going to circle it. Boom, got another one. Pick it up again. There we go. So I've got 3 points circled. What are those 3 x values?
-1.
There it is. Okay? So go ahead and fill those in real quick. Those are our 3 places where it's discontinuous. Okay? Now we're going to give a reason why each one of those points are discontinuous as well. Okay? But before we do, I want you guys to be able to identify points of discontinuity. Okay? Now I'm going to give you student practice, and on student practice there is one spot that we didn't do on this example, but see if you can find it. The idea is, do you have to pick up your pencil at that point? If you do, then that's a point of discontinuity. You ready? So, I don't think I printed this for you, did I?
Yeah.
I did. Great. All right. Now I'm going to give you a hint. There are 4 answers. That's my only hint. And I want you guys to find all 4 points of discontinuity. All 4 x values of discontinuity. Max, give me a point of one x value where it's discontinuous.
X is 0.
He found the hard one. He's right. Weird, right?
Yeah.
But check this out. If I were to start here on the left and just start traveling, that's an asymptote, right? So if I want to continue over here, don't I have to pick up my pencil and move it over here? So x equals 0 is a point of discontinuity. So that was the hard one. The vertical, if you have a vertical asymptote, that is an x value where it's discontinuous. So you got the hard one, Max. Good job. Aaron, what's next? Give me one more. 4. I agree. 4 is a point where it's discontinuous. Andy, give me another one. 2 is correct. And I think there's one more, Christian. 6 is right. So we have to jump over our vertical asymptote. We have to jump over this hole. We have to jump from here to up here, and then we have to jump over this hole. All those jumps that I had to do are at the x values you see on the left: 0, 4, 2, and 6. Okay? Yeah.
For the 4, would it be this one or
Here or here?
Yeah.
There. Yes. Because we're talking about at what value of x does the line break? The line breaks at 4. So it doesn't matter what point you're looking at. The point is that's where it broke. It broke at x equals 4. And that seems to be a common question. So did you guys catch Roxanne's question there? I'm going to say it again. She asked, at 4, which point is the point of discontinuity? Well, the answer I said to her was yes. And the reason I said that is because at what x value does the line break? And the answer is it breaks at 4. It's not about which dot it is. It's just that at that x value, that's where it got broke. Okay. I saw a few people kind of struggling with that concept. So hopefully that clarifies that. All right. Now we need to work on the whys, you guys. We need to figure out why is it discontinuous. You need to learn how to mathematically explain why it's discontinuous at that point. And that's the hard part of today. Okay, is knowing how to explain it correctly. Now, I'll tell you right now, one of your 3 answers, you have 3 reasons why it could be discontinuous, okay? One answer is you could say, because f of whatever is not defined. That's one reason. You would say that one if there's no solid dot at that point anywhere. If there's no solid dot for that value, in other words, you don't have a y value there, then that's when you would say that. Another explanation would be the limit as x approaches c does not exist. That could be another one of your explanations. Okay? You would say this one if the limit from the left and the right are not the same. Okay? If the limit from the left and right are not the same, then you would say this one. The other possible reason you'll give for why the function's not continuous at that point is because you're going to say, well, okay, the function exists and the limit exists. They're both there. The problem is that they don't match. So those are your three possible explanations for why it's discontinuous at that point. So you have to be one of those things. Yeah.
So the vertical asymptote would fall under that middle one, right?
True, but it could also fall under the top, right? If you have a vertical asymptote, you cannot plug a number in to get a y value. So you could say either one and get the correct answer. All right. All right, so let's go ahead and do this. Let's go back to the teacher example now, example 1. So we're going to get off the student practice and jump back to the example. What was my first point of discontinuity here? Okay, so first of all, let's run some tests here really quick. Is there an answer for this? Does the function exist at -3?
Yeah.
What is it? 1. That's not my reason then for it failing to be discontinuous, for it failing to be continuous. So I'm not going to say that one. Let's see if we can find the limit. Does the limit exist?
Yeah.
What is the limit? -1. So the limit exists. Is that the reason?
No.
No. There's only one other reason. It's because the third reason why it may fail to exist is because the limit is not equal to the function. Is that true? That's where it fails. So check it out. What is the value of the function at that point? 1. What's the limit?
-1.
Okay, so here we go. We're going to say x equals -3 is discontinuous there because, so let's write because, f of -3 is not equal to the limit of my function as x approaches -3. So the function exists and the limit exists. The problem is those are two different points. We have so it's not. Let's look at our next one. What was my next point of discontinuity on this graph, you guys? Okay, so I'm going to call on you. Ready? Samantha, if I want to figure out why this is not discontinuous, what's the first thing I'm going to check?
You're going to check all of the lines.
Okay. Well, there's 3 tests I need to run. What's the first test I need to run? There we go. We want to see, is f of that number, does it exist? So let's do that. Is there an answer for this?
Yes.
Okay, so let me call on someone to see if they can tell me what it is. Ryan, what is f of -1? That's right. Do you guys see it?
Oh.
There it is. That's my y value at that point. So is this the reason why it's not continuous? No. It's not because the function fails to exist, because the function does exist. All right, what's the next thing I need to test, Dylan? Good, but what's the math way of saying that?
See if the limit system.
Good. So now here's the best answer, but you got warmer with that one. The answer I'm looking for is, does the limit exist? And the way you do that is what you just said. Is the limit from the left and the limit from the right the same? So now I'm going to ask Brody. Brody, does the limit exist at x equals -1?
Yeah, it's different from both sides. From the left, it goes up to 1, and from the right, it's 2.
Okay.
Well, only sort of. It's kind of straight line.
So you're half right and half wrong. So here's why you're half right. You're correct in saying that the limit from the left is 2, and the limit from the right, no, I'm sorry, the limit from the right is 2, and the limit from the left is 1, right?
Yeah.
But that means something. That means that the limit does not exist.
There isn't one. Right?
There you go.
The
So
limits
yeah.
exist.
So we could say the limit does not exist. And if I were you, in parentheses, I would put because the limit as x approaches -1 from the right is not equal to the limit as x approaches -1 from the left. So I would write that because that's something that sometimes that's required in explanations too, and I want you guys to kind of get used to that. Technically, I think this is good enough, just saying the limit doesn't exist, but sometimes they want to explain why the limit doesn't exist also, and this would be the reason why the limit doesn't exist, because the limit from the left and the right are not the same. Okay? So there's our two, we've got two reasons. So it's not continuous at -3 because the function's value is not equal to the limit at that value. It's not continuous at -1 because the limit doesn't exist, and that's because the left and right hand limits were different. Let's look at one more. What was the other point of discontinuity? 1. So so x equals 1 is discontinuous because. So let's go through our process again. Christopher, what's the first thing I need to check? The function is defined. So let's see if the function is defined. What am I going to plug in parentheses here, Chris? 1. All right. Zach, what is f of 1?
1 is 0.
No. But I'll still give you some points for trying there. Maya, what's f of 1?
The negative
Yes. That's where my solid dot is, right? That's the y value. So is it defined? Okay. So that's not the reason why it's not continuous. Nate, what's the next thing I need to check to see why it's not continuous?
You basically want to you want to see if the limit exists.
There you go. Does the limit exist? So let's write this. I'm going to write limit. What am I going to put under here, Nate?
X approaching 1.
Good. Sam? There you are. What's the limit as x approaches 1? Okay. So what's the limit? Huh? That's right. So it does not exist then?
Do that aim draw.
Okay, so x equals 1 is a point of discontinuity because the limit does not exist. And to be more specific, because I think that's kind of helpful, I'm going to ask, why doesn't the limit exist? So, Serena, why doesn't the limit exist? So this is the reason why it's not continuous. But why is that true? Why does the limit not exist? Let's be more specific. Okay, that's okay. Let's see if maybe Dario can help us out. Why does the limit not exist, Dario?
The limit approaches 1 from the left. It doesn't. It's like the limit approaches 1 from the left.
Beautiful. The limit as x approaches 1 from the left, this is how you write that, is not equal to the limit as x approaches 1 from the right. And since that's the case, the limit does not exist. And since the limit does not exist, that's what makes that a point of discontinuity. So, all right. So I'm going to let you guys try to give your explanations on this one. Now, in your student practice, you guys identified the following points as points of discontinuity. What was it? It was 0?
0, 2, 4, 6.
Okay, I want you guys to give me the because on all of these. Your answer, you really only have 3 possible things that you could say. One thing you could say is the function is not defined. F of whatever is not defined. The other thing you say is the limit does not exist. The other thing you say is the function is not equal to the limit at that point. So those are your 3 possible explanations. Go ahead and see if you can come up with the right explanation for each point. So, Ashley Edwards, you get the hard one.
Why?
I don't. Did you get it?
I put them for X is 0. I thought that I put them in the
So what doesn't exist?
limit, because it's
Okay, so there's actually two correct answers. So here's the thing. You could say that f of 0 is undefined. There, do you guys see a y value there anywhere I could find? There's no y value. So that could be one reason. But she's right also. The limit doesn't exist either. The limit as x approaches 0 for this function does not exist because they're infinity on both sides. Even if they were both positive infinity, you would still say does not exist, right? Because infinity means it doesn't exist. So you could say either one of those. You could have said either the limit fails to exist or you could say the function's undefined. So either one of those would be a good answer for number 1. I'm going to erase that though. Yeah, that's the one most people are getting stuck on. Angelisa, number x equals 2. Why is x equals 2 discontinuous? What's C though? Don't say C. There we go. Now, how would I write that? Don't say equals. Yeah. Equals means there's a number there. There's no number. It's just undefined. Nothing's there. But there you go. That's how you'd write that one. Let's go ahead and move on to number x. Why is x equals 4 discontinuous, Alyssa?
because the limit does not exist.
That's right. And how do I write that? Limit, and what goes down here?
X approaches 4.
Does not exist. And I'm not going to write this part, but I am going to ask somebody, Nathan, if I was asked to explain why the limit doesn't exist, what would I say? Okay. Let me try Juliana.
Oh, wait,
You weren't paying attention? Okay, just kidding. All right, so why does the limit not exist for 4? Yeah. Correct. That sentence was said beautifully. Beautiful. You redeemed yourself. All right, Brandon. X equals 6. Why is it not continuous there?
Because even though the limit exists,
Yes.
it's not equal to f of x.
That's right. So so this is how you'd write it. F of 6 exists and the limit exists, but they're just not the same. F of 6 is probably 4, and the limit is probably like 6. Okay. There you go. All right. Oh, thank you. Yes, that's important. Thank you. That is actually very important. All right. So let's do the opposite now. You guys did a good job. Nice work. Here's what I'm going to do now, you guys. I want to talk about the intervals of continuity. Okay? In other words, we found the points where it's discontinuous, but now I want to talk about what line spaces, what intervals is it actually continuous on? How long can I actually draw a line before I have to pick up my pencil? Okay? So before we do that, I want to remind you of something. Brackets are for closed dots. Brackets mean it can equal that point. Parentheses are for open dots or asymptotes or anything that you can't actually equal. Okay? So here we go. I'm going to go back to the teacher example here real quick. Here we go. For part B, I'm not going to put well, I guess I'll try to squeeze it down here. All right, so let's start on the far left. What is the point farthest to the left? Remember, we only want x values for this. So it's -4. Now, is that a bracket or parenthesis? That's a bracket, because 4 is a closed dot. Comma. Now, I don't have to pick up my pencil until I get to? So that means it's continuous from -4 all the way up to -3. Now, is that parenthesis or bracket? That's a parenthesis. So that's one interval where it's continuous from -4 up to, but not including -3. Now, but we get to continue that now. So let's pick up where we left off. Where did I leave off at? That's where my pencil would start. It's not included. And then I would keep going until I got to what? -1. And would that be a bracket or parenthesis? Where would I pick up at then? I would pick up at -1. Is that a bracket or parenthesis? There we go. It's a bracket until we get to what? Parenthesis or bracket? Pick up at? With a parenthesis, right? And how far does that go? It's 4. I'm glad you're thinking that though, because that is actually one of the answers on your student practice coming up. But it stops at 4, right? Does it make it to 4 bracket, or does it not touch 4? Huh?
No.
It's a parenthesis. An asymptote can't be touched, so it's a parenthesis. Okay?
I was wondering what that was. I thought that was part of your little recording dots. Like, you know, like on the edge of your screen. I thought that's what that was.
Yeah, no, it's an asymptote. So those are your intervals of continuity. That's where there's no holes, gaps, or jumps. So up here at the top, we had the negative side of things. Where is it not continuous? Down here, we have where is it continuous? Okay? Ones up here are points. Down here, these are intervals, ranges of values. All right, so I'll let you guys do that on the next slide here. Now, I want to add some things, though. There are arrows on these, which means they keep going in those directions. Except for this one, I'm going to put a closed dot. Okay? So I want you guys to give me what are the intervals of continuity for this graph. Go through it, see what you guys got. Let's see. Now, I assume that some of you guys, the hardest point is the first one. Where does this thing start at? Starts off at -infinity. It doesn't start at 3. There's an arrow there, right? So it starts off at -infinity. Can you touch -infinity? That's a parenthesis. It keeps going until we get to what? 0. Doesn't touch it, though. It's an asymptote. And then we pick up at 0 again until we get to 2. Now when you're up here, you can't touch the 4. Can't touch the 6.
And then the 7, which you can. Put it 6 just by itself. No, 6 to 7, which you can't touch.
No, you want only intervals, so you don't want to put a point.
Wait, but you put a solid dot. Wouldn't that be a bracket?
You're right. All right. Now, before we call it quits, I want to share with you guys the literacy event. We got 3 minutes? All right.
Let's go. 3 minutes.
Don't call me a nonconformist. I'm complying. Okay, here it is. It's continuity and human impact on the environment.
Yeah.
Are you guys ready? I don't really mean to make fun of all. It's just that we need to teach math. So, but here we go. Extra credit though, so you might want to watch. Ready?
Oh.
Determine if each scenario below represents a continuous function or a discontinuous function. The amount of carbon monoxide in the atmosphere is a function of time. What do you guys think?
It depends on the situation of how much carbon monoxide is used in the atmosphere.
It could be different things, you're right, Nate. But in general, wouldn't you guys say that, do you think it's going up or down?
It's going up.
Okay, say it's up. So wouldn't you agree that it's just going to gradually change over time?
Yeah.
Oh my gosh, the environment.
No holes or gaps, right? But let's think of this. Let's think of Japan. From the year 2000 to the year 2020, what happened?
Oh,
They got
what up,
toxic.
right?
Nuclear bomb.
Remember they had an issue? they had a power plant break with there was nuclear. So how much nuclear waste do you think they started with? Not much, but then right at that crucial year, boom, they had a lot, right? That's discontinuous. You had a sudden change.
It's gonna jump no matter what you're doing because you run the reactor for 5 days, you take a bucket of it out, you throw it in a hole in the ground, you go back to the reactor, you run it for another 5 days.
Good point. So that's your extra credit, is you guys come up with your own stories about human impact on the environment, one that's continuous, one that's discontinuous. That's one, but don't forget, very important extra credit is the lesson on step functions. That'll be a video lesson on Classroom. So you have 2 extra credits and 1 homework assignment tonight. Oh, there's not just 4.